So here I have a function which is a linear over another linear, okay? I want to find the asymptotes, the stationary points, and the axis intercepts, and then I might sketch it. Okay, when I have a linear over a linear, to get the asymptotes, first thing I want to do is write it in the form like this. Some number, okay, over the denominator, plus some number over the denominator. Alright, so to do that, okay, what I'm going to do, so I want to get an x plus 2 up here. So how would I, if I was to get x plus 2 up in the numerator, how would I get a 2x? It'd have to be multiplied by 2. And then 2 times 2 is 4, so how would I get the negative 3? That would be take 7 on top. Okay, so, and that would be all over x plus 2. Okay, so I haven't changed the value of this at all, I'm just changing the way it looks. Okay, basically what you do, you look at this denominator, and you go, right, I've got to get that denominator up in here. So if I was to put it up into the numerator, what other changes would I have to make to the numerator for it to give me 2x take 3? Okay, kind of like factorizing, but not. Okay, so I get in this form here, then that means that is the same as this, isn't it? Which is the same as 2x plus 2 over x plus 2 minus 7 over x plus 2. Okay, and that can be written, they cancel out, that can be written as 2 minus 7 over x plus 2. Alright, so first thing I'll go for is the vertical asymptote. Right, vertical asymptote. If I made x negative 2 here, this denominator would be undefined, okay? And so that means the function would be undefined, that's my vertical asymptote. So the vertical asymptote is at x equals negative 2, okay? So it's when this denominator, x plus 2 is equal to 0, that's how I got that, x equals negative 2. The horizontal asymptote, how do I get that? Well, I look at, as modulus x approaches infinity, okay, what does the function approach? Alright, and that's what I wrote in this one. So if x approaches infinity here, this denominator gets massive, gets bigger, 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 bigger. So this number here gets so small that it's almost 0, so it's 2 take 0. So as modulus x approaches infinity, the function becomes 2. Okay, so that's where my horizontal asymptote is at y equals 2. Alright, so I've got a vertical asymptote at negative 2, horizontal asymptote at y equals 2. Alright, next, stationary points. So let's just rewrite the function here. F of x, what was it? Was 2x take 3 over x plus 2. Okay, so to get the derivative, because I'm looking for the stationary points, local maximum minimum is when the derivative is 0, so I have to get the derivative. It's going to be the quotient rule, so the derivative of the numerator, which is 2, multiplied by the denominator. Subtract the derivative of the denominator, which is 1, multiplied by the numerator. Okay, and that would all be over the denominator squared. Okay, so let's expand the brackets. Gets me 2x plus 4, take 2x plus 3, all over x plus 2 squared. What does that give me? 2x take 2x, they cancel out, 4 plus 3 is 7, so it's 7 over x plus 2 all squared. Okay, so sign diagram for this would be, if x was negative 2, that means this denominator becomes 0, so I've got an asymptote at negative 2. There's no maximum or minimum here, okay, because the derivative is never 0, you can see. Okay, so I've got an asymptote, and so let's sub in a value less than negative 2, negative 3, that'd be negative 3 plus 2, which is negative 1 squared is positive 1, so that's a positive. And if I subbed in 0, I also get a positive. So I've got the function increasing this side of the asymptote and increasing this side of the asymptote. Okay, so that's the nature of my stationary points. I actually have no turning points, okay? Alright, now, what was the other thing? Axis intercepts. How do I get axis intercepts? Well, for the x-intercept, y must equal 0, so the function must equal to 0. So 2x plus 3 over x plus 2 is equal to 0. You can see that 2x is going to be equal to 3. You can see that x is going to be equal to 3 on 2. So the x-intercept is 3 on 2. Y-intercept occurs when x is equal to 0. Okay, so when x is equal to 0, so f of 0 is going to be 2 times 0, take 3 over 0 plus 2. That leaves me negative 3 on 2. Okay, so I've got an x-intercept at 3 on 2, which is 1.5, and a y-intercept at negative 3 on 2. Okay, so that's the x-intercept, and that's the y-intercept. So let's put it all together on a graph. Okay, so let's just have some axes here. What did I find? I found that the vertical asymptote was at x equals negative 2, so that's here. So I've got a vertical asymptote, it's at negative 2. I found the horizontal asymptote was at y equals 2, so that's at y equals 2, isn't it? The horizontal asymptote. I also found that the function has an x-intercept of 1.5, 3 over 2, so that's here, okay, and it had a y-intercept of negative 1.5, negative 3 over 2, which was here. Okay, now my turning point showed me, my sign diagram showed me that the function increases here and then increases that side, so it would be something like this. Be increasing that side of the asymptote, remember it doesn't cross this asymptote here, and then it would be increasing this side, crossing at negative 3 over 2 and 3 over 2. So there is my graph.